you know anything about two-strokes, you know that a good port job and a good pipe are the two biggest things you can do to improve your performance. Well, about a year and a half ago, I decided I wanted to learn how to port a cylinder. And I actually made a video documenting my first time porting. And needless to say, that first setup that I did, it basically did nothing. There was no additional power over stock, which actually isn't a bad thing because the tendency is that most people destroy their cylinders their first time porting. So I consider that in itself a win that I didn't destroy a cylinder. But in the meantime, I've actually ported quite a few cylinders, and I've landed on a setup that on these 400s makes a ton of power. And I'm going to give you guys the specs on that, but I'm also going to show you the mistakes I made along the way to figure out what actually makes power on these, so you don't make those same mistakes and you don't end up with garbage cylinders like this. So before I get into the details of the actual specs of this porting setup, I just want to show you guys that it's actually making good power. I've got a friend with an HPD race mod motor, and if you don't know who HPD is, they built pretty much all the baddest high horsepower machines for the Polaris 400 platform. And the race mod motor, it's got really aggressive porting, a big carb, V-force reeds, the works. And he's running an LRD pipe, so it's a hot setup. And in the first clip, you'll see that he actually pulled ahead on the starting line, and I ended up beating him on the back end. However, you can't see that in the video, so you'll have to take my word for it. And in the second clip, you'll see that I beat him off the starting line, and then I maintained that lead. So anyways, I'll show you the clips now. As you can see, this setup is pretty quick, and the best part is it's got a really broad power band. So anyways, if you're not interested in the details, I'll throw in some more riding footage at the end, but for now, I'm gonna go ahead and get into the actual nitty gritty of how I figured this stuff out. So the first order of business is I upgraded my tools. So in the original video, you could see that I was using a Dremel with a flex shaft, and that tool, it was good for my first time, like it did the job. However, it didn't allow me to get into the transfer ports, which is super important for making power on a two-stroke, which I'll get into a little bit more about that later. But for now, this was really important, and it's reversible, which is pretty cool if you've ever done any porting work. I can't really explain it, but it's an important feature to have. And then this is the actual tool that allows you to get into the transfer ports. It's a 90-degree grinder here. And it, I got it off Amazon. So it's not as high quality as like the name brand tools, but it's perfect for me. I'm doing low volume stuff here. So as far as bits go, I've just been using that set back there, and they work pretty good. I just picked them up off eBay, and I'm sure there's better name brand options out there. However, this set's worked perfectly fine for me with the low volume stuff I've been doing. And then for finishing the exhaust port, I've just been using like just a standard Dremel like drum disc for all my rough sanding. And then for the finer grit stuff, I'll just do it by hand, which there's faster options out there, but for what I'm doing, that works perfectly fine. And then to finish the intake side, I've just been putting in a sandblaster because it gives me a good uniform finish without having to do a ton of work. So I just do my general shaping, and then I just stick it in the sandblaster. So what you're looking at now is actually one of the cylinders that I messed up. And this one I'm probably not gonna run. And the reason is I didn't have a good system for measuring. And by measuring, I mean keeping track of how far from the deck my port heights were. Whenever I first started, I was just pushing a cylinder ring down into the barrel, and then I would use a scribe to mark on my layout fluid. And it sounds stupid in retrospect, but I didn't have anybody to guide me on this. And that was the best method I could think of, and it didn't work. As I was making the marks on this cylinder, the ring migrated, and anyways, with that being said, the transfer heights are all messed up. And while I was learning, I came across a video of Arlen at LED Performance working on a cylinder, and I saw that he was using calipers to measure his port height. And the way that he would do that is he'd take his calipers, and we'll set them down in here. Let's see, there we go. He'd set it, like say this was the port height that I wanted. He would set his calipers there, and he'd make a cut check with his calipers, make a cut, check, and he'd just keep doing that till the entire surface of the roof was at the correct height. And as you can see, this one is pretty inconsistent. The point of me saying all that is that was one of the first major lessons I learned, is I needed a system to keep track of my port roof heights, so that way I could more accurately alter the timing of the cylinder, which, if you don't know, your port timing is what dictates the performance characteristics of the engine. So if you have, I don't know, crazy high blowdown, your cylinder is going to be like a light switch, or if it's really low, I mean, I don't know, because I don't really mess with any of that, but it won't be probably ideal for the CVT setup that we have on the 400s. So if you watch the original video that I made porting, the actual measurements I give on the exhaust port really don't make any sense. I think I said like 74% of the bore diameter, which doesn't make any sense because it was tiny. It was like, I think 60% in reality. And the reason that is because I made my own template and I was taking it and I would flatten it out and measure it flat, which is not how you're supposed to measure your exhaust bore width. You're supposed to measure it from here to here in a straight line, because it's the percent of the bore, right? So your bore is, straight across from here to here in the center, which on a stock 400 is 83 millimeters. And so putting it in the terms of percentage of bore diameter, it gives you like a uniform principle for setting your exhaust port width. And so on this one, I did 70%, which is about the maximum you want to do on a cast iron bore like these are. And the way that I did that was by getting a set of in-bore calipers. And what this allows me to do is to put these down in here and take this measurement. And once I learned the proper way to measure, from here to here, I better understood, how large it needed to be. And then with those calipers, I could actually accurately cut it to that width. So the next lesson that I learned is that I didn't have to alter the angles of my transfers. So the stock angles worked fine for me in terms of like this angle right here and then the actual roof angle that it comes out at. And I just left those the same and altered the timing to my desired timing, and that worked perfectly fine. So you could squeeze out some more horsepower by changing the angles, but what I've been doing, it ran amazing. So I'm still doing some experimenting with the angles, and once I figure that out, I'll probably make another video. So the next thing I started doing, I'm not sure if this really makes a big difference in power, but I did do this on the cylinder I'm currently running that runs amazing. And as you can see, there's these little casting defects down in here where there's no aluminum touching the cylinder liner. And all I did there was I just filled those up with JB Weld and then smoothed them flat. I was a little nervous to do that at first, but I was assured that it would hold up fine. So I did that as well, and the cylinder runs great. So I guess that wasn't a bad idea, but time will tell on that one. So maybe let me experiment and tell you what happens. But yeah, that's about everything that I messed up and learned. And if you avoid doing those things, you'll learn how to port a lot faster than I did. But anyways, getting into the actual specs of the cylinder I have that runs really good now. So I'm gonna start with the exhaust port. We have the timing set at 196 degrees. That's 2.5 millimeters higher than stock. And then I have the width set to 70% of the bore diameter. I'll put the actual measurement and width in millimeters on the screen right now. And then I have the transfers. I left the angles alone. I didn't widen them. All I did was, keeping the same angles, raise them 1.4 millimeters for 126 degrees of timing. And so that puts our blowdown at 35 degrees, which is pretty good given these have a CVT. You can kind of kill the bottom end a little bit and it's more forgiving because you can make up for it with clutching. And then I have the intake opened up to 35 millimeters top to bottom. So that's like the measurement of you have your square intake, top to bottom is 35 millimeters. But yeah, that's the setup that I'm running right now. And just as a note, I am running a race pipe. So I can't guarantee that, it'll run quite as good on your setup, but it's working great for me so far. So next, I want to show you a little before and after of a full throttle pull. So my old porting setup, the very first cylinder I did that I made the video on, versus the current setup with the specs that I just shared with you. And I think it'll be a pretty big difference. But anyways, as you guys can tell, it's a pretty big difference with the porting. And I've got some more riding clips, so I'm going to show you guys those now. Well, this is my latest rendition of porting. And I'm just now getting to open it up, so I just finished the break-in period. And anyways, I guess let's see how this thing runs. well, that's all I have for you guys today. I hope you enjoyed the video because it is by far the most expensive one I've made to date. I spent a lot of time and money, like, figuring this stuff out, and I hope those specs work for you guys. And I could not have done this without Ron at CoreFab. He does excellent work. He's been doing all of my cylinder boring and bracing, and I really couldn't do it without him. So huge thanks to him. If you ever need any work done, you should absolutely go to him. He's a great guy, great customer service. You should totally use him. But that's all I have for you today. Let me know what you think in the comments. Like, subscribe, and hope to see you in the next one.